Hi again, this is Bill Punch from Michigan State University. This is another video in the series of videos, The Practice of Computing Using Python, CSE 231. Today, we're going to talk about comprehensions, a shortcut to doing a common task we do all the time, examining all the elements of a collection. Let's go ahead and get started. So this is something that we end up doing all the time. We go and we look at every element of a particular data structure, number one. And so we look at every element, we perform some operation on each element, and then we collect them up in some other data structure. This is so common that a shortcut has been created called a comprehension that makes it easier to write this stuff. But a couple things, some warnings, right? While shortcuts are short, obviously, they can make things difficult to read, and so that's a trade-off. And always remember that if you can do something the long way, if you have a way that you know how to solve a problem, do it that way. When you become more experienced, shortcuts might become more it's easier to pick up, but don't let this stuff throw you. It's not that big a deal. So a comprehension really has four parts, right? The kind of data structure we're going to collect, a list, a dictionary, or a set. An expression for every element that's going to be collected, the data structure we're iterating over, and optionally a condition that determines when an element is collected. Let me show you a picture for what would be called a list comprehension. Here is a list comprehension, and here are the four parts in color. So it's a list comprehension because we're enclosing this expression in square brackets. If we were enclosing it in curly brackets, that would be another story. We'd be collecting a set, a dictionary. Here, we're collecting list elements. So we're going to make a list at the end of this. The kind of data structure we're going to generate is dictated by the end elements. In this particular case, we're going to generate a list because we have square brackets. If it was curly brackets, it could be a set or a dictionary. What we are going to collect are these elements, whatever an element is squared, and so we're going to make a list of elements, each one squared. We are going to iterate over this list and collect a single element at each time. And then at the end, we're going to ask the question, if the element is even, we're only going to collect it under those circumstances. And so if I evaluate one of these expressions, so let's make a list of numbers in the range from 1 to 10. And let's go ahead and run that expression. What we get then is in the elements 1 to 10, we're going to collect, every time an element is even, we're going to collect it by squaring it. And so 2 is even, we square that. 4 is even, we square that. 6 is even, we square that. 8 and 10. All right, you could have done this as a longer version. There's certainly an easier way to write it using regular for loops. Here it is. It gives exactly the same results, right? The difference is that this is a shortcut. It actually turns out that these shortcuts are more than just shortcuts. They're also quite a bit faster. We're not terribly worried about speed at this point. So here's another example. We make a dictionary of Bill 100, John 200, Rich 300, Fred 10. This is a complicated expression. Can you figure out what it does? Here are the parts. So here is the comprehension from square bracket to square bracket. What we're going to collect up is the key values as a tuple, only we're going to collect them as value key. We're going to reverse the order, and that will generate a list. That list is fed to sorted. Sorted sorts those tuples. What is the basis for the sort? Right? For a chunky item, when we do a sort, we sort by the first element in each tuple, so we're going to sort by the values. Sorted returns a list. When we get the list back, we're going to take the last one. That's the tuple with the largest value. From that tuple, we're going to get the large number and return it. So one expression is going to return from a dictionary the largest value, which is 300, which is exactly right. You can also make set and dictionary comprehensions just by changing the enclosing symbols. Just like with sets and dictionaries for construction, if you're collecting key value pairs, you're making a dictionary. If you're collecting elements, you're collecting for a set. Let's make a new dictionary. We're going to zip together Bill, Fred, Irving, Sam with 10 through 40 by 10s. There they are. This is an expression to take the values of the dictionary and then make a new dictionary where the values are now the keys and the keys are now the values. So Here is the iteration for key value in the dictionary items. We're going to collect it up as value keys. It's going to be a dictionary at the end. We get the new dictionary with the keys and the values reversed. What's the key for index 40? It's going to be same. Here is for making a set. Because we are collecting not key value pairs, but just elements, this means we're getting a set. We're going to iterate through characters in the string. The condition is going to be that the character be in string.ASCII letters, so no punctuation and no spaces. We're going to collect all those characters up. What are we going to do before we collect the characters? We're going to lowercase every character, and then that's going to make a set. We'll get all the unique letters of the set. Lastly, here's a nice little operator. It has to be the case that the expression you put up front, the thing that you collect, be an expression. It can't be a control statement like this. You can't put an if statement. You can't put a while statement. You get an error, right? But there is a new expression called a ternary expression, which is a kind of a shortcut if statement that is in fact an expression, returns a value. It has 3 parts. The first part is what gets returned if the condition is true. The second part is the condition that we're going to measure. And the third part is going to be the expression that gets returned if the condition is false. So either this or this is going to get returned depending on whether this condition is true or false. This one for true, this one for false. And we can use those. Here's an example. If the age is 20, if your age is greater than 18, you should return mother. Otherwise, you should return mom. There it is, mother. If I make it 15, return hi mom, one or the other. And we can use that in a comprehension. This is going to be a list comprehension. What are we going to do? This is the expression that we're going to collect. If I is even, we're going to square it. Otherwise, we're going to cube it for every I in the range. If we do that, that's exactly what we get.